work similarly to regular Punnett square problems, except that you're going to separate males and females. So we're going to talk about males and females separately when we get to phenotype. So let's look at some symbols that you're going to use. Some of you are probably already familiar with some of these symbols. The XX symbol is the symbol used for females. The XY symbol is the symbol used for males. Now, when we get ready to apply this to working problems, we're going to need to attach some letters to them. So we've got X capital B is going to be homozygous normal female. So whatever trait or disease we're talking about, this individual has two capital B's. That means they're normal. The XX means that this is a female. XX means female. We got a capital B and a lowercase b, that's heterozygous normal female. We also call her a carrier. X lowercase b is homozygous recessive, and this time she is affected because she's got lowercase b. So these are our females. The symbol you usually see associated with female is this symbol, and I'll be using that quite a bit when we get ready to work a few problems. The normal male, X capital BY. Notice Y doesn't have a letter here. All right. Capital B means normal male. Lowercase b here means affected male. There is not a heterozygous because there's not a corresponding letter on the Y chromosome. Remember that when you're talking about chromosomes, humans have 46 chromosomes. That's 23 pairs. If you were to list all the chromosomes, you'd come down to the last pair. And remember, chromosomes are kind of roughly X-shaped, sort of. And so that's kind of where we get the XX from. So if that last set is XX, it's a female. If it's XY, it's a male. So let's work a problem. In humans, baldness is a sex-linked recessive trait. Predict the outcome between an affected male and a female who's a carrier. So how would we write an affected male? Of course, since it's a male, it's going to be XY. Since the male is affected, we're going to use a lowercase b there. A female who's a carrier, of course, female is going to be XX. She's a carrier, so she's going to be heterozygous. Now we're going to work our Punnett square. And different teachers will tell you different things, but as far as I'm concerned, I don't care which one you put on the top and which one you put on the side. It'll work out to be the same thing. Okay. Now in this particular case, I don't list the genotype. I don't have my students list the genotype. So on problems that are sex-linked, I don't care about you knowing the genotype. I mean, I care about you knowing the genotype and what it is, but as far as listing on the problem, it won't count off if you leave it off. The thing I'm interested in on these type of problems is the phenotype. Remember, we're going to separate it based on male and female. So let's look at our females first. These two boxes are female. This one has XB, X lowercase b. This one has XB, lowercase b, X lowercase b. We're only looking at the females. We're ignoring these two boxes at the bottom. We're completely ignoring those two boxes. So on these phenotype, 50% of the females, capital B, lowercase b, that means they're going to be normal. Yeah, you could put carrier here, but remember you're dealing with phenotype. Carrier is more related to the genotype. In this case, they're normal if they're a carrier. I can't tell the difference between capital B, and capital B, lowercase b. And 50% of the females are going to be affected. Now, why you may ask, why is it 50-50 and not 25-25 like we've done in other problems? Because remember, we're ignoring the males. You're only looking at these two boxes. 100% would be both of these boxes. 50% would be one of these two boxes, because we're only looking at the female. All right, now let's look at just the male. These two boxes. 50% of the males. That's the symbol we're going to use for males. It's also the symbol for Mars. Males are going to be normal, 50%, and then 50% of the males are going to be affected in this particular problem. Now we separated the males and females. Remember, we're only looking at two boxes. We're ignoring the females down here. We're just looking at the males. 50% male chance of being normal, 50% chance of male being affected. Now this is important, especially in human genetics, when you're looking at diseases and things. And once you determine the sex of the child, you can give a different opinion based on this. And we'll look at this in a different problem. In some species of goats, having long beards is a sex-linked recessive trait. Predict the outcome between a normal male and a female who's a carrier. All right, a normal male is going to be written this way. A female who's a carrier, as we discovered in the last problem, is going to be written this way. And you're just going to fill out your Punnett square. Like so. And remember, we're not going to worry about genotype. I just want to know phenotype. Let's look at just the females. These two boxes are female because they're XX. Capital B, capital B, capital B, lowercase b. In this case, 100% of the females are normal. And I know you may say, well, hey, 50% of them are carriers and 50% of them are normal. They all appear normal. In this case, they all would have this long beard that we're talking about. Oh, excuse me, I guess having long beards is a sex-linked recessive trait, so they'd have a short beard. So let's look at the males now. We're only going to look at these two on this side. On this side, you got capital B and a lowercase b. So 50% of the males are normal, and 50% of the males are affected. Let's look at one more problem. In humans, Rashi syndrome is a sex-linked recessive trait that causes a person to be born without toes. Okay, yeah, I made this disease up. It's not real. Predict the outcome between a normal man. The normal man would be X, capital B, Y, and a woman who has this disease. Remember, in order for a female to have the disease, it's going to be lowercase b. One of the reasons why sex-linked traits are more common in males than females is that females have 2/3 chance of being normal, whereas males have a 50-50 chance of being normal. So let's do our regular Punnett square. And of course you're going to fill it in just like you always have. This time when you're ready to write phenotype, remember we're only going to look at the females. This is the box at the top. 100% of the females are going to be normal, even though it was mama who had the disease. All the female offspring are being normal. Down here on the male part, 100% of the males are going to be affected.